Welcome all, this is another video in topology series. In this we'll see path components and locally connected spaces. What is path component? If we consider X to be a topological space and consider two elements X and Y in X, and if we define a relation X is equivalent to Y or X is related to Y if there exists a path connecting points X and Y in X, then this relation will be equivalence relation and the equivalence classes will be path components. We'll see how it is equivalence relation. For reflexivity, if we have X in X, then X will be equivalent to X because there will exist a constant map f from closed interval AB to X such that f of t is equal to X for all t belonging to closed interval AB. Now we'll get to the symmetry. Suppose X is equivalent to Y. Then what does this mean? There exists a path joining X to Y. So let us consider f from closed interval 0 1 to X such that f of 0 is equal to X and f of 1 is equal to Y is a path. Then we can consider the function g such that g of t is equal to f of 1 minus t for some t belonging to closed interval 0 1. Then what will happen? G of 0 will be f of 1 which will be equal to y, and g of 1 will be equal to f of 0 which will be equal to x. So g will be path from y to x. So y will be equivalent to x if x is equivalent to y. And now remains is transitivity. For this, consider x is equivalent to y. What does this mean? There exists a path f from closed interval 0 1 to x from x to y in x. And also consider if y is equivalent to z, then there will exist path say g from closed interval 1 to x from y to z. Then if we consider a path edge from closed interval 0 to x such that h of t is equal to f of t when t is from first interval, that is from closed interval 0 1, and h of t is equal to g of t when t belongs to the interval 1 2, then h of t will be a connected path from x to z, and thus x is equivalent to z, and thus transitivity holds.